Hi, in today's video I'm going to be covering an update to my FFmpeg scripts. So what are these? These are a collection of FFmpeg shell scripts for basic video editing tasks. So I'll go through what the scripts are and the updates that I've done. So this is a list of all the scripts. So what we've got here is some scripts, and I'll just go through them. We've got things like audio silence, and that's for adding blank audio to a video clip. Combining clips, that's for combining an image and a audio track into a video, or combining a video and an audio track into a new video, so basically swapping out the audio track. We got stuff for scene detection, to automatically detect all the changes in a video and chop the video up into individual clips using a makefile. So you just run one command and it will chop up an entire video into clips. We got correcting clips with GIMP curves, an EBU meter which uses FFplay to show the audio levels. We've got stuff to fade clips in and out, normalize the audio, convert an image to a video, loud norm, normalize. These are to normalize audio levels. We've got overlay clip, which will overlay a clip over another video. We've got overlay picture in picture, so that's picture in picture video. We've got stuff like adding subtitles to a video file. So what this will do is it will take a subtitle and add it as a subtitles track. It won't burn it in. It will allow you to add a subtitles track you can toggle on and off. We've got video scopes, like you get in a video editor for histogram, that sort of thing. You know, you'd get in Final Cut or DaVinci Resolve. We've got stuff for converting videos into GIFs. We've got something to print out the waveform of a video, so the audio levels. We've got stuff to convert a video into webp. We've got all the Xfade transitions from FFMPEG. And finally, we've got zoom pan, which is the Ken Burns effect. So what I've done is I've gone through all of these scripts and actually removed some errors and shell checked them all. So what shell check is, it'll basically throw up errors or syntax errors in your code. And as you can see down here, we've got a nice little tick. So if I go through all these, you'll see that these are, let's go through, you can see most of these have all got nice little ticks on them. And let me just show you one that hasn't. There's one or two that don't, like here, and you'll see it's got a lot of errors. And this is basically, let me see. Yeah, some of these errors are basically false positives. So what I'm going to do now is actually go through all these, some of these scripts down here and show you how they work. So let's switch across to the terminal. And what I've got down here is two videos, Big Buck Bunny and Elephant's Dream, which are both open source videos by the Blender Foundation. And I'm using that so there's no copyright issues. So we've got like Big Buck Bunny here. Okay, so first of all, what I'm going to do is I'm going to remove the audio track. So audio silence -H. So basically what we do is this script has got defaults, which you can override with these options here, but we can basically just run audio silence -I, give it a file, and what it's going to do is replace the audio, the audio track with silence. You can also take a video file that doesn't have an audio track and add silence to it. The reason for this is because two use case scenarios. One, some video sites complain, or video players complain, if a video doesn't have an audio track. And secondly, you might have a situation where you've recorded some footage, you know, done a screencast or something, and you're muttering away in the background, and then you actually think, oh, I need to use that for something, and you don't want you muttering over the video. So what we'll do is audio silence -I, Big Buck Bunny. Okay, so Big Buck Bunny silence. We've removed the audio track. So that's that script there. So image to video. So what we can do is we can actually extract. Let's go through sort of one by one. So we've got combine clips. So what we can do with this is combine a image with a audio track or a video with a new audio track. So what we can do is we can dump out the audio track of one of these and combine it with the video of another one. So what we'll do is run FFMPEG input elephant stream, and the way you dump out an audio track without the video is by specifying -vn. So that's kind of like video null. If you do -an, that will not dump out the audio track. So FFmpeg in elephant stream -vn. What we're going to do is copy the audio track, and we're going to call that we'll call that ed.m4a. I think it's an m4a, is it? No, it's an opus. So what we're going to do is change that to AAC, ed.m4a. Yeah, overwrite. Give that a second. What this is going to do is it's going to dump out the audio track from that video. Typically, the audio and video tracks for stuff on YouTube will be VP9 and OGG audio. So what we've got here is this M4A.
We can see at the right we can.
Okay, so you can see that's the audio dumped out. So what we're going to do is take that audio and combine it with Big Buck Bunny. What we're going to do is run combine clips -h for the help, and this gives us the option. So combine an image or video file with an audio clip. So first thing is combine clips -i, and the in file can either be a video or a image. Then we specify a audio file and optionally an out file name. So combine clips in Big Buck Bunny audio ed return, and what this is going to do is it's going to shorten the audio or video depending which is the shortest. So it will basically make the audio match the video length, or the video match the audio length, as it were. So what we've got here is Big Buck Bunny combined.
We can see at the right we can see the hat snarlers and everything. One move.
So that's basically replacing the audio track of a video with another audio track using combined clips. So let's now extract a image and then combine it with that audio. So what we can do is we can run extract frame, and what this will do is extract a frame from the video. And this is useful because you can actually seek into the video and extract a frame, and you can also use all of these scripts with the find command, so you can actually batch process stuff. And this is the reason why they're written with an optional out file name. They'll have a default out file name so that you can actually use them with scripts, and it will automatically generate an out file name based on the in file name. So as you can see up there, it says Big Buck Bunny -combined and then the time and date. That's automatically added so that each file has a unique name, and also tells you which script that's actually been run. So you can see it's been running with the combined clip script. So let's extract a frame now, and my cursor seems to disappear. So, okay, extract frame, and what we want to do is give it an in file, and we'll do let's do elephant stream, and we're going to seek to say 30 seconds, so hours, minutes, seconds. Okay, that's it. You now see we've got this PNG file here, and give elephant stream PNG. Okay, it's a bit of a shit grab, so let's remove that one. And let's do that again. Let's do it. Let's do it a 50 seconds to see if we get something better. Okay, that's a bit better. So what we're going to do is combine that image with that audio file we extracted. So the way we can do that is combine clips -I, give it the image -A, and give it the audio file. And what this is going to do is it's actually using FFprobe here to analyze the audio file. And what it's doing is it's actually hasn't just crashed or anything. It's going through the audio file and counting the number of seconds. Once it's done that, it stores that in a variable, and we then use that variable and specify that the image should be created for that length of time as a video, and then we combine it with the audio file. As I say, this is a 10-minute video, so having to go through and actually get the duration, and now you can see it's kicking in. And what it's going to do is it sort of calculates the image frame rate divided by the duration, and once it's done that, you'll see we've got this file here, elephant stream frame combined. So MPV elephants frame combined, and you can see this is just a static image that lasts the full length of the video. So let's have a look at the file size there, and that's about 30 meg, and that's because it's 10 minutes of audio. So let's crack on and go through some other stuff. Okay, I won't do the correct clip, and what that does is that basically uses GIMP curves to allow you to alter an image in GIMP, adjust the brightness, the level of the contrast, and save the curve settings that you've used. You can then use those curve settings and apply them to the video and color correct the video using the curves you created in GIMP. So it's a way of actually color correcting video by using GIMP to adjust the image and then apply those settings to the video. It's pretty mad. So next thing, EBU meter. Another thing I should mention is, let me come across to the FFM projects and come across to here, and what I will do is open up this page. So what I've done is not only have I fixed the errors, I've organized all these, split them into sections describing what they do. So up here we've got FFplay EBU meter, and under each of the headings what it'll do is actually list the dependencies for the script. So you'll know which tools you need to have installed for it to actually work. So we got what the script is, the dependencies, this is the script usage, the error messages, number of arguments passed to the script, get ops, variables, and then the function. So EBU meter, this requires FFplay, and sometimes FFplay isn't actually bundled with FFmpeg. So just on a side note, let me just switch back here and come across to my config. Yeah, config, Nix, home. So this is Home Manager. This is how I install everything on my programs. And what I found is NixOS allows you to install all these different things, and they all have different package names. And I had FFmpeg installed, and what I found is the FFmpeg package on NixOS or NixPKGs didn't have FFplay rather. So I've installed FFmpeg _5-full, and that's FFmpeg 5 with FFplay and things like the mvenc encoder enabled. So that's just a little side note. So you may need to check your distribution to see if FFplay is installed, but what we do is give it an I option and then a video or an audio file. So we'll give it Big Butt Bunny. And I managed to pick one that didn't play. I think that's because it's using the Opus codec, and I haven't set this up for the Opus codec. So let's find one with actually works. See if Elephant's Dream works. So yeah, so I need to fix the codecs that it uses. So I think those are all using. I'll use the ED one, okay, because I know it's AAC. EBU meter ED. Okay, there we go. So what this will do is it will actually show you the audio levels up here, the LUFS, that sort of thing, and you can use this with the normalize script to actually normalize the audio levels and check what they are. So that's the EBU meter. We've got fade clip. It's the sort of fade clips to to another clip. That's sort of like an old one. I've got several fading ones. I won't go through them all. Image to video. So let's have a look. So we've got an image. We've got this Elephant's Dream frame here. So what we can do is turn that into a video and specify the duration for the video. Let me just top my T up. So which one was that? Image to video. So you can run all these scripts with the -H option, and it will print out the help and the options that you can use. And also the supported file types. So you can see in file .png, JPEG, that sort of thing. So with this script, we give it an in file, a duration in seconds, and optionally an out file. So for a minute, it's going to be 60 seconds. For 5 minutes, it's going to be 300. So image to video, in file, Elephant's Dream, give it the PNG, give it a duration of 30 seconds. And we can optionally set an out file name, but if we don't, it's going to automatically create one. So we'll just call this img2 video.mp4. There we go. img2 video. As you can see, that's now a 30-second video clip. So as I said, that's just a video track. So suppose we want to add the audio track. So what we're going to do is do the audio silence and add a blank audio track to that. Just saying that, for example, if I upload it to some site and it complains, or you're using some video player on Windows or something, and it won't play. This is a way around it. So we'll do audio silence, give it the in file, We don't have to specify. We can specify, you know, the channel, mono or stereo, 44, 100, 44, you know, whatever, for the bit rate, but it's got default, so we don't need to give it an out file. We'll just call it silence. Sod the spelling. There we go. MPV silence. You can now see it's got a audio and video track, 1044 100. So that's how we can add audio silence to a video that doesn't have a video track, as well as replacing a audio track with a blank one. So now norm and normalize, these are for basically normalizing the audio. What we'll do is go through the overlay clip and overlay pip. So overlay clip -H, overlay one video clip on top of another. So what this will do is it will replace the video at a certain portion, at a certain start point, with another video for a particular duration. So you can use it to kind of like just replace that bit of video. So what we've got here, let's just clean up some of these. Let's stop demo. Let's get rid of some of these unused ones we got here. Okay, so silence, that's a 30-second thing there. So let's trim out a section of video and then insert it over another section. So we got keep doing that. So what we got is Elephant Stream and Big Buck Bunny. So let's go through Elephant Stream.
Listen,
just find a mad section. Where's the one with the mad flower? Hang on, this is a nice section. Oh,
email.
Let's just.
This way.
What we're going to do is we're going to grab. Okay, so.
Follow me.
Stop it here a second. Make a note of timestamp. Okay, so what you'll see here in the console terminal is the output from MPV, and what you'll notice in the timestamp down here is we've got milliseconds as well. Okay, and I showed you how to enable that. I'll switch across to my mpv.config. mpv.config. I think this is the one. Oh yeah, this is the bit. This is so in your .config mpv.config. What you need to do is add OSD-fractions, and what that's going to do is show milliseconds in the on-screen display. So let's get back there. So you can see here. What I want is hours, minutes, seconds, milliseconds. So 666. Okay, so it's obviously the devil's work. So what we're going to do is 0138 666. So start 36. Was it 0136 666? Jesus, no memory. So we give it the start time, the input file, Elephant Stream, and then 2. So what the 2 option means is the number of seconds after the start point. So this isn't, say, if you wanted to record to 2 minutes 06, you wanted to start at 1 minute 36 and go to 2 minutes 6. it's 30 seconds, not 2 minutes you put in here. So to record a 30-second clip, we do this. We don't specify the playhead position, as it were. We don't specify 2 minutes 06. We specify we want to record a 30-second clip after 1 minute 36. So just press return. That's going to trim the clip. And what we'll do is we'll create a short clip from Big Buck Bunny of, say, 2 minutes. So what we've got here is we got the trimmed clip. So what we'll do is trim clip start. We'll start the beginning of Big Buck Bunny, and what we want to do is, let's say, create a 3-minute clip. So 2 hours, minutes, seconds. So much quicker than using a video editor. And the problem on Linux is all the video editors, apart from DaVinci Resolve, are terrible. And DaVinci Resolve, the free version, doesn't support H.264 and AAC. So you have to convert the footage to DNx HD, which increases the file size by 10 times. So if you've got a 1 gig bit of H.264 footage and you want to bring it into DaVinci Resolve, it's going to you're going to have to convert it to 10 gigs of footage before you can import it. So right, what we've now got is Big Buck Bunny trimmed and Elephant's Dream trimmed. So what we're going to do now is overlay clip. So overlay clip -H, overlay one video clip on top of another one. So what we do is we've got the in file for the first clip and -V for the second clip and the position in seconds. And what this is the time at which you want to insert that clip. So what we're going to do is run overlay clip, give it the so the first one is the bottom video, and the second one is the top, if you see what I mean. So the -V option is the clip that we're going to use to insert over another clip. So we've got Big Buck Bunny trimmed, -V, Elephant's Dream trimmed, and the position, let's say we want to do it 30 seconds in. So what this is doing is it's going through that whole video, the whole Big Buck Bunny video, first of all, which is 3 minutes long, as you can see by the time down here. And it's inserting that video over the top of it at 30 seconds for a 30-second duration. And once time gets to the end, it'll have created the new clip with the overlaid clip in it. Here we go. So, as I said, if you look at the file names here, what you'll see is that they all contain the original file name dash the clip that's run on them and the time. And so you can see this one here saying like trimmed and then overlay. So Big Buck Bunny trimmed overlay. And I'll just leave this running till it gets to 30 seconds. So you can see there we took a 30-second clip and then overlaid it onto the other clip at the 30-second point. So that's the overlay clip script. So let's go through and just clean some of this stuff up again. So what I want to do is actually, I'm going to remove that one there. So what I want to do next is run overlay picture in picture. So overlay pip -h, overlay pip, create a picture in picture. So these are the options: -i, the in file, -v, the next file, -p, the position, -m, -x, -w. So you'll see down here, these are all listed and what they do. So the bottom video and the top video, the time to overlay the video, the margin, we've kind of got a margin, we've got the position of the picture in picture. So top left, top right, bottom left, bottom right. We've got width, so defaults to quarter of the video size. I need to add the zero and the O there. You've got fade, so it actually fades in and out, and you can change the fade. We've got a border around the picture in picture, and we've optionally got a color for the border as well. So let's see if we can get this working. So what we got down here is the 2 trimmed clips. So what I'm going to do is the big bunny one's 3 minutes and that's 30 seconds. So I'm going to reuse those clips and do a picture in picture. So overlay pip -i, the bottom file is the big bunny trimmed. The top file is going to be the elephant's dream trimmed. And the time position, we want to do this, say, let's do this 10 seconds in. -m is the margin, we'll leave that. We'll leave it default to top right, fade. We'll leave all the defaults. We can just do out pip.mp4. As you can see, it's going through the video. So what I'll do is, after I've gone through a demo of this, I'll go through some of the scripts and just clean them all up. Hopefully I haven't broken anything. But I do check all this before I actually push it up to GitHub. So we've got pip there, so mpv pip. So you can see what happens there is it actually puts the main thing into the picture in picture and then puts the other one as the main video, as it were. Main video, and it goes into picture in picture. When that's finished, switches back. So what you can do with that is, let me just switch across to picture and overlay. There's the overlay pip. So as I said, you've got all the options down here to change the position. So top left, top right, bottom left, bottom right. The width, so you can change the width of the picture in picture, the border, color, all that kind of stuff. So that's the picture in picture script. What else have we got down here? Pan scan, so that's panning up and down a videos. We've got pan scan and zoom pan there, like Ken Burns effect. I won't go through all of these. Scene cut, detect. These are all for scene detection. So what I'll do is I'll do it with a short clip. So make directory scene detect. Okay, so what I'm going to use is the little trimmed clip so that it doesn't take ages to do the demo. So this is the 3-minute clip. So CP big butt bunny trimmed scene detect .mp4. So scene detect. So now what we're going to do is do scene detection using a makefile. So let's come back across here, and what we got: makefile, scene detection, makefile, raw. And what we're going to do is we're going to save this makefile. Okay. And we're going to move that downloads makefile to here and have a look at it. Demo, scene detect, makefile. So what this does is it will run a series of scripts one after another. So we have 3 scripts that we use to perform scene detection: scene detect, scene time, and scene cut. Scene detect analyzes the video and then creates a text file with all the scene changes in seconds. And what we have to do is use another script called scene time, which will actually format it into a sort of format, as it were, that FFMPEG can use to go through the video, seek into the video, and then create the clips. And the scene cut script is what we use to take that text file and then the video and then seek into it and chop up the clips. And this will basically automate the process. And the way we use it is we just basically run makefile input equals and then the file name. So let's check if I've messed anything up with these scripts. So make input. I'm not getting the flipping input. See, on ZSH, I was getting the input equals vid. Oh God, have I not got make installed? Oh, for God's sake! This is one of the things about NixOS is that what I found is some tools that you would think that you'd have installed by default actually aren't installed. So like, for example, the file command wasn't installed, and it seems like make isn't installed. So I'll actually have to skip this one here and move on to another example, Sod's Law. Let me just come back out of that. But I did actually do a video about the scene detection. So subtitle add, that's for adding subtitles. Let's have a look at the scopes. So let's just come back out of that video, that directory. So scopes -h. So what this is FFplay video scope. So you basically run this script with one of these options to use one of these scopes on the video. So histogram, RGB, parade, RGB overlay, and parade, waveform, vector scope. So let's go for these options: -I, O, P, S, W, V. So scopes -I, and we'll give it Big Buck Bunny. As you can see here, we've got the scopes up there. So that's the that was the histogram. Then we got the -O for the RGB overlay. So that's scopes -O for the overlay. Okay, so that's the overlay. Scopes -H. Then we got P for the RGB parade. Scopes -P. Big Mutt Bunny. S for the RGB overlay and parade. Scopes S. What's the next one? Waveform. So scope /w big rock bunny. And lastly, the vector scope. So scope /b. So this is an interesting one. This actually will show the vector scopes for the colors, and what this can be used for is checking if skin tones are off. So this is a vector scope, and you'll be able to see sort of like suddenly someone's got like really green skin or really blue and that sort of thing. So that's quite useful. So tile thumbnails. So what we'll do is we'll go through these ones: tile thumbnails, vid clip, trim clip. So tile thumbnails. So what we got here is Big Buck Bunny. So what we can do is run tile thumbnails -h, tile thumbnails from a video into an image. So what does that do? It creates like a contact script, strip of all the thumbnails, of a selection of thumbnails for the duration of the video. So it will show, you got like a 10-minute video, it will show thumbnails from the beginning to the end of that video. So these are the options: -I, the in file, seek, width, TPMC. So what are all these? So in file, yep, so that's the video that you want to run the script on. Seek, so this will seek into, this is the start position where it will create the thumbnails from. So for example, you may have a video that starts with a fade to black and then goes into the video. You don't want the first frame of the contact strip to be a black frame. So by default, what the script does is it seeks 5 seconds into the video. So what you need to do, if you want to start at the very beginning, you run -s 00:00:00, and that will then capture the video from the beginning of the strip. And the other thing this can be useful for is, suppose you start all your like YouTube videos with an intro, yeah, and you don't want to print out the thumbnails from the intro. You can say, okay, start creating the thumbnails from 30 seconds, so that it just creates it from that point on. So we've also got the thumbnail width, so default 160. We've got the tile layout, so 4x3, padding between images, we've got margin, and we've got color. So what we're going to do here is run tile thumbnails, give it the in file Big Buck Bunny. So we'll give it Big Buck Bunny, which is a 10-minute video. Let's set the width to 320, so they're a bit bigger. 4x3, 7, we'll leave it just default like that. As I said, what you can do with these scripts is it's kicked in there. You don't have to specify an out file, and the reason for this is so that they can be used with batch process stuff. So nskiv, and we want the flip. Did we just run that on? Hang on. Big Buck Bunny, yeah, okay. Tile, Big Buck Bunny tile. So nskiv. So you can see there we've got 4x3, 320 images, starting the beginning or 5 seconds in, and then going to the end. So what we'll do is we'll overwrite the start point. And what we'll do here is we'll specify the start option. Doesn't matter which order you use these in. Give it a second. Okay. So nskiv Big Buck Bunny tile. Second one. and you can see there that starts with a black frame. So that was what I was mentioning, is that a lot of videos will fade in from black. So that's why by default I add a little 5-second head start so it doesn't capture a black frame. So that's the tile thumbnails. And as I said, you can change the width of all the thumbnails. You can change the rows and columns. You can change the padding, the margin, the color between all of these, so you can have white or black or whatever you want. This is a really good way to generate a load of thumbnails showing kind of the action of the video. So next up, after that, where did we get to? Tile thumbnails, trim clip. Okay, so let's have a look at the trim clip script. So this is for trimming a video or audio clip, and you can see here it's actually listing the dependencies. You need FFmpeg and file. So this is the actual script, and see here, trim all these different kind of audio and video files. So trim clip -h. Okay, so what we've got here is these options -s, -i, -t, and -o. So first of all, we run trim clip with the -s option and then the start time, and this is in hours, minutes, seconds, and milliseconds. Then what we do is we give it the in file, which can be a video or audio file, and then what we do is we specify the -t option with hours, minutes, seconds, and milliseconds. And this is the number of seconds after the start time. So again, if you wanted to have a start point of 1 minute and record to 2 minutes, the -t option is going to be 1 minute, because not 2 minutes. If you put in start 1 minute and the end time 2 minutes, it's going to record from 1 minute to 3 minutes. So kind of make sure you get that in your head. The -t option is the amount of time after the start point, not the actual position in the video or audio file. So what we got here, let's just do a trim as I showed you before. So we'll trim Big Buck Bunny, trim clip -h again. So the start time, so trim clip, give it the start at the beginning, give the in file, Big Buck Bunny, 10 seconds, give it, pull it out, 10.mp4, off it goes, done, mpv 10.mp4, do it too quickly. But as you can see here, that's a exactly 10-second clip. So same deal with audio. How long is that audio clip? Okay, that's 10 minutes. So let's do the same thing with the audio clip. That's a AAC file with an M4A extension. Trim clip. Same thing. Head. Time. Remember to give it the right sort of file extension. So basically out 10.m4a. Here we go. MPV 10-second audio clip. So that's the trim clip script. Basically, what you got up here is again the dependencies. When you run -h or give an incorrect command, it's going to print out the usage here. You check the amount of arguments passed to the script. And we got the get ops, and this is the how you set up the options for the script. So what you have here is while get ops, and then you have the actual options listed here that are listed down here in this fashion. So -:s And you need to start it with the colon so that it can do some error checking. As you can see here, start time, input, end time, and what you'll see here is -s start equals opt arg, and what that means is that's the argument passed to the option. So when you run -s or when you run -i and give it an infile is going to be equal to the opt arg, which is the name of the file you gave it. Okay, so then what we've got here is variables. So this is how we can get the infile name and the infile name without a path. So this is how you can actually get just the infile name that we can then use to create the output file name automatically. So whenever you run the script, it's going to, if you don't give it an out file name, it's going to create the output file name based on the input file name with the dash trimmed and then the date and time. So what we do is we use the file command to actually check the MIME type here of the file, so that later on in the script what we can do is we can check what MIME type the video or audio is and then run the correct function. So that's the trim clip script. What we next got is vid to GIF, waveform, webp, Xfade, and zoom pan. So vid to GIF, let's have a look at that. So vid to GIF -h, convert a video into a GIF animation. So let's take that 10-second video clip we created. So vid to GIF, we'll give it the infile, and we'll just use the defaults 10.mp4. So this is a GIF, and then we've also got webp, which is better quality, and hopefully I can get that to work. And I've got everything installed on what do you call it, NixOS, so NSKIV. So NSKIV is community fork of SKIV. We've added capability to play animated webp images. So let's see if this works. There you go. So you can see there's a small GIF of that 10-second video. And it's looping because I use the -a option with NSKIV. So that's with the GIF. We've got waveform. So waveform will print out the waveform from a video or audio file. So let's just use it on that 10-second audio clip. So waveform, was it again, -h, just give it the in file and obviously the out file. So 10, there we go. Let's v 10.waveform, and you can see, I think it's just because it's maybe I'll do it on another bigger one. So waveform in Big Buck Bunny, trimmed. I think it's just because it's how do I zoom in on this? I'm not sure how. Forget how I zoom in. Oh, there we go. So that sort of creates oh, I've zoomed in too much. That sort of creates a sort of waveform. It's just I've got it sort of zoomed out a lot, but you can see that's a sort of waveform of the audio levels in the video. So next we got webp. So what that is that's creating an animated webp, like a GIF but better quality. So let me just clean up some of these unused things. Get rid of some of these. Just clean some of that up. So which one is it next? WebP. So WebP-H, WebP animated image. So what we got here is input, compression type, quality, frame rate, width, and then we've got presets like photo, drawing, picture. So let's see if I've got everything installed properly. To do this, WebP in 10.mp4, and we can actually just leave it at that. So nskiv-a. That's much higher quality. You can see there's actually a bit of pixelation and banding up here. That's just because it's something with a fade. But this is an alternative to animated GIFs. But a lot of sites don't actually support WebP as yet. So that's WebP. We've got Xfade. So Xfade is all the FFMPEG fades that you can use. So what you can do with this is specify a fade between two clips. And what you can do is you specify the first clip, the second clip, the duration of the transition, the type of the transition, and the offset. And these are all the transitions that you can actually use. And these are all on the FFmpeg wiki page. So these are all the transitions that FFmpeg can use. And I think you need to have FFmpeg 4.3 or above. I forget which version it is. So what we want to do is have two clips. So let's use those trimmed clips. So what we'll do is Xfade. We have specify A and B, which I thought made sense. So A, it's going to be Big Buck Bunny trimmed, and B is going to be Elephant's Dream trimmed. And what we can do is specify the transition, and I think I said a default transition. And I actually did a whole video on this with showing all the different transitions. So I'm not going to go through all of them one by one because it takes a while. So I'll just do it with the default. So I can specify that file name. So we'll call that xfade.mp4. As you can see, this is going through. Surprised that Nix didn't have make installed. That's really weird. So I have to install that, but I did test the scripts manually, so there shouldn't be anything wrong with the scene detect scripts. But let's play this Xfade clip now. Okay, so that was just a regular sort of cross dissolve. So if we just come back to H here, so let's just show you one or two. So I'll do the circle close. So what I'll do is I'll do the same thing here. --t circle close. Put that out for circle.mp4. So this was two clips. One was 30 seconds and one was like 2.5 minutes. So obviously the second clip is added after the end of the first clip. Yeah. Just in case you're wondering. So MPV circle, and what I'll do is fast forward to the position in the video where the transition occurs. So you see there, we've got nice so see if I can find the actual page. Xfade, yeah, this is the one I was on about. So you can see here, this is the these are all the transitions you can use with the script. So all these ones listed here. So what we've got here is actually an animation of what they look like. So if you want a reference of what the transition is before you actually go through and use it, go through and manually try out all the transitions, you can come to this page and actually see what the transition looks like. So that was like the circle close one we had there. So there's all the transitions that you can use with that script. So that's the Xfade, and then finally we got the zoom pan, which is, as I said, like a Tim Burns type thing for zooming up and down images. So those are all the scripts, and you can see all the ones I've sort of updated here. So as a brief go through, just check, show you that they're all sort of error free. So this is the audio silence script, the dependencies FFMPEG and FFprobe, script usage, error messages, the get ops, the variables down here. So we've got stuff like setting the default options. What we also do is check for the AAC codec. So there's the FDK, libfdk AAC, which is the Fraunhofer AAC codec, but that's typically not supplied on a lot of distributions, and you may have to manually install it. So what we do is we check if you've got that installed or not. So if you've got it installed, we'll use it. If not, we'll fall back to the regular AAC. And then we've got the functions down there. So as you can see, that passes the shell check. Clip time. This is for scene detection, where you just want to extract particular clips, so you can specify like start and end points for sections of video you want to extract, and then just basically chop the video up automatically. We've got the combined clips down here. This is the one where we combine an image or video clip with an audio file, and these are the dependencies: FFmpeg, file, and grep. You see no errors down here. So this is how we're sort of we're running a case statement. We're checking whether you've got whether the audio file is AAC or if it isn't, and then running particular functions. We've got correct clip. This is for correcting video clips using the GIMP curves. We've got crossfade clips for just doing a simple crossfade between two clips. So the crossfade is just a simple version to do a simple crossfade. If you want to do transitions, you want to use the Xfade clip. Then we've got the EBU meter up here, which has got FF play as a dependency, and again some builds of FFmpeg in particular distributions won't ship with FF play, so make sure you got it installed if it's not working. We've got extract frame. This is to extract a frame from a video, and again we've got a nice little spelling mistake there, which obviously shell check doesn't pick up my spelling mistakes. That's comprehensive education for you. And we've got the spelling mistake repeated down here as well. Ah, class. So that's extracting a frame. And again, this can be used with the find command. And there's examples on the README so that you can basically batch process a whole load of videos and say extract a frame at 30 seconds from each one of these videos. Fade clip. This is fading audio video in and out. We've got stuff like sort of fade title. What this will do is it's got a few errors in this one. I didn't look at. Yeah, sometimes we get these are false positives for this. If you unquote it, the script won't work. So sometimes you get false positives with this, but this will take the video title and add it as a lower third and fade it in and out. So like if you had an interview with someone like Liz Truss, who's back in the news, and you call the video Liz Truss expletive, and that would be the title of the lower third. We've got the image to video, which was turning a image into a video of a duration. Then we had the loud norm and sort of normalize for normalizing audio levels. Overlay clip. Let's see here the one error. So what you'll see here is this error for this command I'm using, expression. Expression is antiquated. Consider rewriting this using da 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 da. This is a false positive. Expression's a perfectly fine command. It's just shell check. Sometimes throws up these false positives for stuff. Overlay pip. See, there's a couple of errors down here. Again, about the expression command, and we've got this stuff. Modification is local to a subshell. This is this is another false positive because what I'm doing here is I have a variable called border, and if it's not set, it falls back to border default. So what this allows you to do is in the scripts they all have defaults, but you can override them. So that's why you don't have to typically write out a long command. You can just write out a short command and accept the defaults or override them one by one. Pan scan. This is like again Ken Burns type thing. These are the scene cut. These are all the scripts for the scene detection. You can see there's a lot of errors in this one, but again, a lot of these are actually due to quoting issues, and they actually need to be quoted this way to actually get it to work. So you can ignore these sort of errors here. Scene images, and this will allow you to, when you do scene detection, it creates a text file with timestamps of all the scene changes. What you can do is run the scene images script with this timestamp file and the video file, and it will then create images at all those scene change points. So you'll basically have a load of images showing all the scene changes in the video. We've got scene time. This is one that converts the scene detection time format into something FFmpeg can read. We've got the scopes down here, again, nice and clean, no errors. This is for the video scopes with FF Play. Subtitles adds. This is again for adding subtitles to a video. And basically, this uses a SRT or VRT. No, it's just SRT subtitles file. And what it does is it adds the subtitles file as a track to the video file that you can toggle on and off. It doesn't hard code the videos and the subtitles over the video. It will, it's like soft subs as opposed to hard subs. Then we've got the tile thumbnails, and this is for creating the contact strip from the video. And the dependencies for this are FFmpeg, ffprobe, awk, and BC. And BC is like a command line calculator that we use to perform some calculations to actually create the thumbnails. Then we got the trim clip down here, and you can see nice and clean, no errors. The dependencies here, FFmpeg and file, got the script usage, error messages, get ops, all the variables. We check the MIME type. There's also an issue with the file command where it can wrongly identify a M4A audio file as a video file, so we correct that error. We set some default variables, and then we have all these functions here for actually trimming the different audio and video types. And finally, we've got a case statement where it will check the MIME type of the audio video file and then run the appropriate function. Then we've got vid to GIF, no errors, waveform, clean, webp, again, that's clean. Xfade, got 3 errors down here. Again, these are sort of false positives because, again, see this syntax here, dur equals default and duration default. Again, this is a syntax you can use to sort of specify a default and have it overridden. And finally, zoom pan there, so that's clean. So the few errors that are in the actual scripts are mainly either false positives due to quoting issues or because they're flagging up the expression command as being antiquated. So that's a list of all the updates to the FFmpeg scripts. So I have to check I did check the scene detection scripts one by one. So actually, let me just check the scene detect. I can just do these manually. Oh God, was not wrong with my typing today. So scene detect -H. So I can just specify scene detect in the in file. Okay, so I just want to show you this actually works manually. So we've got the vid detect. So that vid detect. So what you'll see is this is a list of all the scene changes in hours, minutes, seconds, and milliseconds. But this format can't be used by FFmpeg. We've got to run another script. So we would then run the scene time script. So we give it the inputs. So let's just rename that text file. So we'll call that detect.text. Then we'll give it the scene time input text, and then we'll give it an out file name called cutlist. Give it the extension, just you know, bat cutlist. What you'll see now here is let me show you the first one. Detect bat detect. So this is the first one here. You can see changes like this. Okay. Look at the second one, and what we've got is a format like this: the start time and then the duration of the clip. So these it'll seek to hear, and it will create a clip of this duration. So finally, what we then run is the scene cut clip. Scene cut. Give it the cut file and the video file. So scene cut in file vid, and give it the cut list. See, now what it's doing is it's looping over all those timestamps, seeking to them, and then creating all the clips for the specified duration. So I just wanted to show you the actual scene detection still working, even though the make file wasn't working for me because I don't have make installed, surprisingly. I forget how long this actual video I was doing is. I'm just going to leave this to chunder away, and what I'll do is I'll just switch across to the scene cut script. So this is the scene cut script currently running. And what we've got down here is this is the whole script down here. This block of code, what it does is it goes while if equals comma read r start duration trim video and then expression. What does that do? So if we actually look at the in detect cut list file, what you can see is we got two things separated by a comma. We've got the start time, the comma, and then the duration. So what this does is this loops over and it sets anything before the comma to have a variable of start, and anything after the comma to have a variable of duration. It then runs the trim video function above and passes those variables in, start and duration, and creates a clip. So it just loops over that video, that cut list separated by a comma, seeks the point in the video and then cuts it up. So that's now all done there, and what you'll see is we've got a list of all these files, and you see these are all the clips. So those are all the clips created. Let's just go back to that actually. So you can see those are all the clips, and you can see they're all numbered sequentially. So the original file was vid.mp4, so vid-1, 2, 3, 4, etc. So I haven't broken anything, hopefully. I've gone through all those scripts there. So I've removed a lot of errors, cleaned up the code. They do exactly the same thing. So all you need to do is do a git pull down the latest version, and you know, check them out. There shouldn't be any errors with anything. I've gone through and tested everything, and as you can see, I've gone through and shown you how they all work. And this is how you basically install them. I've done a whole series on of videos on this. As you can see, here's the link to the playlist on YouTube. So that's all the FFmpeg scripts updated, and the reason for these is to do a lot of stuff that you'd normally use a video editor to do, just a lot quicker. Because typically on a video editor, you're going to have to, you know, if you're using DaVinci Resolve to do stuff on Linux, you're going to have to convert all your footage to DNX, import it into DaVinci Resolve, create a new project, put stuff in the timeline. Then once you've done that, you're going to have to export it to DNX again, and then convert that DNX footage back into H.264. So using DaVinci Resolve on Linux with the free version doesn't have any support for H.264 or AAC. The Pro version has support for H.264 video, but not AAC audio. So even if you're using the Pro version of DaVinci Resolve, you're still going to have to convert your H.264 footage. You're going to have to convert the audio to get it into DaVinci Resolve, and you're going to have to convert the audio after you've exported it as well. So this is a list of all the scripts, what they all do, how you can install it, and I'll put links to all these bits and pieces under the video. So that's all for now.